All right, so today we are going to draw a model for scenario number 4 here, and then characterize what it would look like at the macroscopic level using the data in the data table. So many layers to a problem like this. So my scenario says that I have 4 moles of solid lithium metal reacting with 3 moles of aqueous barium sulfide. Predict the products of this reaction and write a balanced equation. So I have lithium, which is a solid, reacting with barium sulfide, which is aqueous, so in solution. For my single displacement reactions, the metals switch places. So I will produce this metal that was in the solution will become a solid with no charge. And the other metal, this lithium, will join the anion or the negative ion that is left behind when the barium leaves. So I will also make lithium sulfide. Notice the subscript here for my lithium sulfide is 2. So lithium is +1, sulfur is 2-. So I would need 2 of those positive 1 ions to balance the charge of 1 of those sulfides. So every time you make an ionic compound, you do have to consider the charges of each ion in the compound. Okay, then I will just balance the equation, and then we can start our modeling. So I will need 2 lithiums here to balance the 2 on the right. All right, now I'm ready to start modeling. When I'm modeling, I have to look at the scenario. So up to this point, we've been modeling just the balanced equation, but now in the problem, it's telling us how much of each reactant we have, and that's what we need to draw in the reactant box. So I have 4 moles of solid lithium and 3 moles of my aqueous barium sulfide. Okay, so let's draw in our 4 moles of solid lithium. Those will go at the bottom of the container because they are solid and would sink. And then I also will not put charges for my lithium solid because we only have charges when it's an ionic compound. I also, lastly, I'm going to put this box around it. That just signifies that this is a solid. All right, then it says we have 3 moles of barium sulfide. So I will have 3 bariums and I will have 3 sulfides. Barium is a 2+ ion. And because it is aqueous, I am showing that charge. And then my sulfide is 2-. So 1-to-1 ratio for every barium, there's a sulfur. All right, then I need to determine how much product I can make given this amount of starting material. Okay, so at this point now I'm going to look at this balanced equation because that is the recipe for the reaction. And that will tell me how many of each reactant I need to produce a set of products. In this case, it will be 1 barium and 1 lithium sulfide produced from every 2 lithiums and 1 barium sulfide. So I will partition off 2 lithiums and 1 barium sulfide on the left. And then I have enough, actually, to create 2 times this amount of product here. So I'm going to partition again 2 lithiums and 1 barium sulfide. So then on the right, I will make 2 sets of these products. So I'll make twice as much as what I see here in the balanced equation. So I will make 2 bariums. Those will sink to the bottom. On this side, they do not have a charge because it's a solid. Okay, so they're on the bottom, no charge, 2 of them. Then I will make 2 of the lithium sulfides. So for my lithium sulfide, I have 2 lithiums for every 1 sulfide. So I have lithium, which is Li+. In this case, on the product side, it does have a charge because it's in an ionic compound, S2-, S2-. Okay, and then my very final step is to draw in my excess reactant on the product side because it is still present when the reaction is done. So I need to copy that over on the right in exactly the form that it is. So since it is aqueous on the left, it will also be aqueous on the right. So I have a barium 2+ and S2-. Again, this is excess reactant. Okay, you can then go through and check, do you have the same number of all of the ions? So does your model show law of conservation of mass? This will help you in case you model something incorrectly or you forget to write in those excess reactants. So I see 1, 2, 3 bariums, 1, 2, 3. I see 1, 2, 3, 4 lithium, 1, 2, 3, 4. On the left, 1, 2, 3 sulfide, 1, 2, 3 sulfide. So I have shown the law of conservation of mass, and I know that I have more than likely constructed my model correctly. All right, then there are some questions here about what the resulting product container would look like. So first, my limiting reactant. The limiting reactant is the thing that we ran out of. Notice that's not the barium sulfide because I still see that in the container. So in this case, I ran out of my lithium metal solid. If I filter the resulting products, what would I see on the filter paper and what would I see in the flask? So for that, I'm really looking at this box and then I'm using the table to show what it would look like, to determine what it would look like. So I have barium solid. That barium solid is black and, I'm sorry, I just circled the wrong thing. That barium solid is metallic black. So I would see that. I would not see this solid lithium because it is completely consumed or used up in the reaction. And then for the aqueous solution, I'm going to see lithium sulfide aqueous and barium sulfide aqueous. So it's going to be a mix. So it's going to be black and white solution. You could even go on to say that that would then, the resulting color would be a gray solution. I would really accept either. All right, hope that makes sense. And let me know if you have any questions.